So we're running both compressors now since a while, and the temperature's actually quite alright. We looked at the one thing, the first suspicion I said was that the compressor is burned out. So what you can do, you can open this port. This is the inspection port. You open it and you extract a little bit of the gas mixture, and in there's the gas, the refrigerant, and the oil. The oil is circulating together with the refrigerant in like a kind of vaporized form. So when you extract a little bit of gas here, you will have oil on your fingers, and this is the oil that circulates in the system to lubricate the compressor. This oil and gas mixture obviously also cools the stator winding. The winding of the compressor is in the same circuit, and it gets cooled by the refrigerant. So if you smell, if it gets overheated, the varnish on those windings will give a very distinctive burned smell. So you can actually, by this letting out a little bit of oil and smelling it, you can pretty much see whether this compressor has overheated or it's burned out. If it burned out, you will actually see the oil being very dark and dirty, and obviously it will have this distinct burnt plastic kind of smell. And in this case, we did that. I put a little oil out. You can see there's a little oily, and it doesn't smell burned at all. So the compressor, I don't think it is actually burned out. Also, the winding amperage has pretty much stabilized. There's the electronic controls. We bridged those to make sure, there's a variety of sensors on the system, to make sure they're not messing with our diagnose. So we're running this in a purely mechanical way. The temperature of the compressor is quite alright, and what we're looking at also is the superheat. The superheat is kind of the opposite on the subcool. So what we have here, you can see the gas comes in, and this is a reversing valve, so you can actually use the system as a heating as well. It's a gas operated reversing valve, so it's a little electric solenoid which then uses the pressure of the refrigerant to reverse the system and run the refrigerant the other way around. So you can actually use this as well as a heating instead of a cooling. Now we're using it as a cooling, but it could also be used as a cooling. So gotta make sure that this valve is in the right position, which it is. You can feel it here on the pipes. What happens then is the expansion valve. It goes down and it goes into the heat exchanger. In this box, that's the heat exchanger, this stainless box. What that does, what happens in there is the refrigerant absorbs the heat, which gets transported there through the cold water. So down here you have the circulation pump. This is the chilled water circulation pump. That's the raw water pump. We still have our tank set up there on the scale. So what we're looking at here is how much, obviously down here it's coming there at sub-freezing temperatures. The gas expands, goes into the heat exchanger, and up here it comes back up. So it comes back out, it's expanded. And what we're looking for is how much higher is this temperature versus its saturation temperature. The refrigerant saturation temperature at a certain pressure, how much higher is the temperature in this pipe. So to see that, we can see our pressures here. We're running here at about 40 psi on the suction side. So then we know our saturation temperature, and then we can take the temperature reading on this pipe and see how much higher that is. And that's called the superheat. So the superheat is the difference between the saturation temperature of the gas and the actual temperature coming out. So how much more thermal energy has the gas absorbed after its state change. And that's a little confusing because the subcooling, which we measure up here, it might actually be warm to the touch. The condensate, in this case it's quite cool, but the condensate temperature could actually be warm to the touch, and that's called the subcooling. So the subcooling might be warm to the touch, and the superheat, which superheat sounds like very hot, but it's actually cool to the touch. Because what it means is not in a perceptive way hot or cold. What it means is how much more temperature is there or how much less temperature is there compared to the saturation point of the gas. And the saturation point of the gas is obviously very different with different temperatures. At higher pressures, like we see here on the high side we've got 275 psi right now, that saturation temperature is much higher. So this is subcooled liquid, and although it's subcooled, it may be warm to the touch, although it is subcooled relative to its saturation point. The same thing here, superheat may feel cool to the touch, but it is actually quite hot compared to the pressure. So superheat might feel cool to the touch, and subcool might feel warm to the touch. That's a little bit confusing, but it makes sense. And they're both looking quite alright, they're both superheat and subcool, and the amperage is also looking good. The other thing important, like when you charge gas, like this gas is a mix of different gases. They have it's a blend of different gases. And why it is a blend is they put different gases, different molecules in there, like say pentafluoroethane, like bigger molecules to carry more thermal energy. And what happens is when you fill the system like this, when you fill a lot of gas in, if you have the bottle standing the right side up, you may fill more, one of the two molecules might boil off faster than the other. So when you're filling a lot of gas, like say extracting all the gas out of the system or putting all the gas back into the system, it's advisable to put the gas tank head down. So then you're filling liquid and you're going to get the proper blend. You're not going to have the one molecule boiling off faster than the other, and you might not get a good refrigerant charge in your system. So when you're charging, if you put a little bit in, it's okay to have it the right side up, but if you put a lot in, you should really have it head down. It's also much faster because you're charging liquid instead of gas.